Hi everyone, Mr. Armitage here, and today we are doing another two-column proof for a couple of perpendicular lines and proving that certain other lines are parallel. So we are given that AB bisects angle DAC. So let's see here. I'm going to highlight that. We are given AB bisects DAC. AB bisects DAC. Okay, that's good to know. We are also told that CB bisects ECA. That's good to know. So we are told that those are angle bisectors. AB and CB are both angle bisectors. Told that the measure of angle 2 is 45 degrees, so I'm going to go ahead and put that there, 45 degrees. And we are also told that the measure of angle 3 is 45 degrees. And what we are hoping to show is that the line AD is parallel to the line CE, or the ray, more specific. AD ray is parallel to C, the ray C. Now, how are we going to do? The key lies in bisectors, in this case. Okay, we'll get there. But first, let's write down our given information. Okay, we are told, first off, that AB bisects this angle DAC. Okay, I'm just going to give that particular reason and just that one statement. Because from there, we already know something. We know that the angle DAB should be congruent to the angle BAC, because that comes directly from the definition of an angle bisector. Because we cut it in half perfectly, the angle here and the angle here are equal to each other. And now we have another given piece of information. Right? We're told that the measure of angle 2 is equal to 45 degrees. By the way, this is my own mistake. I could have said BAC is angle 2 to make this simpler, and the angle DAB is really angle 1. So we'll make that simple. Sorry, I'll keep moving forward with the numbers. Now, because the measure of angle 2 is 45 degrees, that was given to us, and we know that angle 1 is congruent to angle 2, that would mean that the measure of angle 1 is also equal to 45 degrees, right? Because that is simple substitution. We knew that angle 2 was 45 degrees. We knew that angle 1 was congruent to angle 2, which meant that the measure of angle 1 was equal to the measure of angle 2. Measure of angle 2 is 45 degrees, so the measure of angle 1 is 45 degrees. Now, I'm going to include an extra step and say that the measure of angle 1 plus the measure of angle 2 is going to be the measure of angle DAC, because that is simple angle addition. And that sets us up for another thing, for our next statement. Okay. So the measure of angle 1 was 45 degrees. Measure of angle 2 was also 45 degrees, and that's equal to the measure of DAC. And that's everyone's favorite as well. That's also substitution, because we just replaced the variable, the measure of angle 1, with the actual measure of that angle, 5 degrees. Simplification or addition, whatever you want to call it, this means that 90 degrees is the measure of angle DAC. So I'm going to call that simplified. Which would mean, by definition, that angle DAC is not the angle DAC, but because the measure of angle DAC is 90 degrees, that means the ray AD is perpendicular to the line AC. The ray AD is perpendicular to the line AC. By definition of a right angle. Great. We did that. We showed that one particular ray was perpendicular to the base of sort of our pyramid, I guess we could say. Now we have to do the same thing to show that CE is perpendicular to AC. Okay? Now we could do all of these steps again. Okay, but what I want us to kind of see here is that we do have a sort of symmetry across this. Okay, so everything we just did was on the left side. Okay, we showed that the two angles 1 and 2 were congruent. We showed that they added up to 90 degrees, which meant that AD was perpendicular to AC. Likewise, same steps would follow to show that CE is perpendicular to AC. So rather than write out 7 steps again, I am going to say CE is perpendicular to AC. And the reason I'm going to give for that there could be a lot of reasons, a lot of ways you could say this, but same steps as 2 through 8. But with the other side. Now, obviously, you're not going to see that on like a test or something like that unless it's free response. But if it was completely free response, I would have to grade that by hand anyway and expect to see a lot of different types of proofs and a lot of different flows for the proof. But now we're basically done at this case or at this time because of this, AD is parallel to CE by one particular theorem. which I'm not a super fan of the name, but whatever. It is the lines perpendicular to a transversal theorem. Okay? Which all that's saying is that if you have, we'll say AD is parallel to, or perpendicular to AC, and CE is perpendicular to AC, right? AC becomes the transversal, and then we have two lines that are perpendicular to it. That means that our lines that are perpendicular to that transversal also have to be parallel, which is exactly what we were hoping to show. There, our proof is complete.